So on the 2.2 part 1 assignment, it asks you about where is the function increasing and decreasing. So let's talk about that really quickly. Imagine that you're riding on this parabola like it's a roller coaster. On the left side of this parabola, you're zooming downward. That's decreasing. On the right side of this parabola, you'd be climbing the hill and it'd be like that, you know how roller coasters go. So it is going to be increasing on the left side of this parabola. It is going to be, oops, I totally just did that backwards, didn't I? Yep. It is going to be increasing on the right side of this parabola. It is going to be decreasing, I need to write that word, on the left side of the parabola. So I think on your assignment it asked, like, it is increasing on the right side from x is greater than, I think it's greater than or equal to 4. This symmetry line is the line x equals 4. So on the right side of that, the graph is increasing. On the left side of that line, the function is decreasing. So it's decreasing on the left, and that's the x values less than or equal to 4. And I don't know if in there, if it does greater than equal to, or just greater than, less than equal to, or just less than. But basically they're asking what x values is the y values of the graph increasing, and for what x values are the y values of the graph decreasing. If I could remove that portion of the problem from it, I would. I really just care more about domain, range, maximum, minimum value, vertex, that kind of stuff. All right, let's move into vertex or into intercept form. There's a bunch of descriptions up here, up above. By the way, if you're working forward, we are going to change example B. So I'm going to change that right now so that if anybody chooses to work ahead, they have that change already down in their notes. We're changing example B so that that 2 in front is a negative 2 in front. So just FYI, we are changing example B. Okay, example A. Intercept form looks like this. A times the quantity x minus p times the quantity x minus q. P and q are the x-intercepts. The x-intercepts are where the parabola crosses the x-axis. What I want you to notice is in that formula it says x minus p, but then positive p is the intercept. X minus q, but then positive q is the intercept. So basically take the opposite of the numbers in the parentheses, and those are your x-intercepts. So in this example, our x-intercepts come from here and here. Anyone want to take a guess what the intercepts are? -2 and +4. And I'm going to write them as ordered pairs. So -2, 0, and +4, 0. You take the opposite of those numbers, and those are your x-intercepts. So on my graph, I'll put an x-intercept at -2 and an x-intercept at +4. Okay, so we'll call that step 1. Get your x-intercepts from the equation. Step 2 is find your axis of symmetry. Yesterday we used the formula opposite of b over 2a. This formula, there's no b, a, like there is an a, but there's no b. Basically, the axis of symmetry, because a parabola is symmetrical, the axis of symmetry is going to be perfectly halfway in between those 2 points that we just put down. So you can use your fingers and just count in and find the point that is exactly in between. Now, what if you can't? What if it's not obvious? If you look up in the steps up above, it says to do p plus q divided by 2. That's finding an average. Take the 2 intercepts and find the average. So if we did -2 plus 4, that's 2, divided by 2 is 1. Our axis of symmetry is at 1. Next, we find our vertex. what is the first part of our vertex going to be? 1. Your axis of symmetry is always the x value of your vertex. To find the y value of your vertex, you need to plug in the axis of symmetry value. So we're going to take 1 plus 2 times 1 minus 4. I'm going to write it in with color like that so you can see where that 1 came from. 1 plus 2 is 3. 1 minus 4 is negative 3. That gives us negative 9. So our vertex is at the point 1, negative 9. Okay, here's what I love about intercept form. The only math we really had to do was plugging in the axis of symmetry value. With standard form, you have to do some math to find the axis of symmetry, then you have to plug that number in to get the rest of the vertex. With intercept form, you can just count and find the halfway point pretty easily, then plug that number in. So I feel like intercept form is a little bit less work than standard form. Okay, once we have those 3 points, we can draw in our parabola. We didn't really talk about it a whole lot, but the a value is still going to do everything that the a value has done in all of the other forms. So this graph is not super wide or super narrow. That makes sense because the number in front is a 1. The graph opens up. That makes sense because the number in front is positive. Okay, does this graph have a minimum or a maximum? It has a minimum because the vertex is at the bottom, and the minimum value is negative 9. Remember that minimum value always matches the vertex. What about the domain? All real numbers. And the range? Y is greater than or equal to negative 9. Again, that minimum value, all of the y values are bigger than the minimum value. If we wanted to talk about increasing or decreasing, this graph is increasing to the right of the symmetry line, and the x values to the right of the symmetry line are x is greater than or equal to 1. The graph is decreasing on the left side, and that's where our x values are smaller than 1. So if it asks you about the increasing, decreasing, it's just which part of the graph is going up, which part of the graph is going down. Okay, let's try example B. First, we need to identify our x-intercepts. Our x-intercepts are going to come from this -7 and the -3. So what are the x-intercepts? +7 and +3. The symmetry line is halfway between those. What looks like it's halfway between 7 and 3? 5. If it's not obvious, you can do 7 plus 3, which is 10, and 10 divided by 2 is 5. So find the average of the x-intercepts. Our vertex starts with the axis of symmetry. We need to plug that number in. So I guess I'll do my work right over here. -2, 5 minus 7, 5 minus 3. So that's -2 times -2 times 2. -2 times -2 is +4. +4 times 2 is 8. So 5, 8. All right, this parabola feels a little bit more narrow Is it surprising that it feels a little bit more narrow? It has a 2 in front. That's going to make the graph more narrow. This graph opens down. It has a negative in front. That's going to make the graph open down. Does this graph have a minimum or a maximum value? It is a maximum value because the vertex is at the top of the graph. And that maximum value is 8, the y value of the vertex. Our domain is all real numbers. How about the range? Y is less than or equal to 8. This graph is increasing on the left side where our x values are smaller than 5. This graph is decreasing on the right side of the parabola where our x values are bigger than 5. We're basically just splitting the parabola down that symmetry line, deciding which side is the line going up, which side is the line going down, and then making the x values fit that. All right, your assignment is 2.2, part 2 in Big Ideas Math, which means you go to Clever, then go to Big Ideas. If you have not finished the 2.1 or 2.2 part 1, those would show up in your overdue tab. So if you're looking for an assignment and you're like, it's not there, check your overdue tab. Make sure that you don't have anything in your overdue tab. All right, have fun.